Alrighty, I believe I'm recording. What's going on, everyone? Sorry. What's going on, everyone? Day 28, almost hitting a month now, man. When did I start this? Day 1 was 3 weeks ago on... Give me 1 second. Sorry. Day 1 was on... Yeah, it's just 3 weeks ago. Oh, June 2nd, man. June 2nd. So, tomorrow will be a month. Tomorrow will be 1 month. So, yeah. Thank you guys for the support. Whoever's watching this, let me share my screen. Thank you for the support. So, today, let me check one thing real quick on my phone. Today we're gonna do okay, cool. Today we're gonna do we're gonna finish everything on Linkless. Guaranteed. I'm not getting out of this chair until I finish everything here on Linkless, and then we'll see what happens. So I had a problem with this yesterday. I'm not even gonna lie. This was an issue. Let's reset. So let's start from the beginning. Remember, remember the push method on our queue is O of n instead of O of 1 because we shift everything to the right. Right, so then we want to fix that using faster queue. You use linked list instead of regular array. Right, so a linked list is where elements are not stored next to each other in memory. Instead, each item references the next in chain. So yeah, remember the node right here. The first node is value is 69 and is referenced to the next node next to it, which has a value of 42. Whatever. So our nodes will represent a simple class with 2 fields, the value and then next, which is the reference. Alright, that's pretty much it. So this was just a linked list versus a list. As you can see, a linked list, it has a reference and a value and nodes and stuff. A list it's just I guess, as it says, are stored next to each other in memory, and to get from an item from a normal list we use numbered index, right? So 0, 1, 2, 3 as it shows there. So if we want to get car equals car 420, we'll get the 400th and 20th. It's just the 421th item. Yeah, it's just the item in the 421th. Remember, 0, so just -1 and -1. Anyways, as you can see here, let's insert our node in the middle. So if we want to insert the node in the middle between the index is 3rd, so we want to put it in between the 1 and 2nd, which will be the 2nd one because it'll go up 1. Anyways, we're gonna have to shift everything to the right, and if you shift all the items down 1 spot, it will take over in time. But a linked list is once you have the traversal to a given node, it'll be O1 because you just simply all you need to do is find the reference, find the node in the middle, and then find the 2 nodes, and then find in the middle, and then reference the left node to that, and now it's in the middle. And then remember, this is not a reference to anything. So okay, cool. That was a quick review. Now we have to focus on iterating. Even though iterating is everything good, yeah, okay, cool. Even though iterating with linked list kind of sucks compared to simplicity of arrays normal lists, we've got to do it. Although the implementation is more complex and slow, we can still make it easy for users of our class by providing an iterate method. The yield keyword. The yield keyword in Python returns a value. The the yield keyword in Python returns a value, kind of like return. However, it is used to turn the function into a generator function. Into a generator function. A generator function creates a new function object. When that function is called, it executes the code in the generator function until it hits a yield statement. At that point, the function pauses and returns the value of the yield statement, which calls picks up the right where it left off. So if a gen equals create animation is the first, next gen second. Okay. Every time you get a comment, it creates a generations. Okay. Just a bit confused on some certain things. I am a bit confused on what is going on below. I am learning linked list. What's the okay with? Think of it like return where it pauses a function instead of ending it, and lets the function remember where it left off and continue from there the next time it's called. Here's what's really happening. So here's what's going on behind the scenes. High. The function doesn't return all three values at once. Instead, it returns a generator object that can be values from one at a time using next. So gen creates the generator. First next gen, the first gen, then it pauses. Then if you call the next one, then you can print the next gen to be there. Print the next one's friend. How does this connect to linked list? In the linked list, I don't think we're supposed to look at that. Okay. Okay, assignment. The linked list class is a wrapper class that uses node class we already wrote. It completes the init method. It should return head field to none. Okay. So okay, the linked list class, right? The linked list class is a wrapper class that uses the node class we already wrote. And the node class we already wrote. Alright, that one. No other node points to the linked list head first, so the linked list class itself needs to keep track of it. Head node, no. So nothing points to the head node. The direction of flow is obviously really the same. Above, I'm using arrows to show which node I'm pointing to. If my queue using this will add until I move elements from the head. So I guess the so we need to complete the element. It should set the head to none. So this head node should be set to none. What am I supposed to do? set the first node which is the head to none. So is it head? So is it so inner method? You're asking. I know the first inner method needs to set the first node, which is head to none. So is it self.head none? Yes, you're thinking right there. So, what does a brand new linked list look like before any nodes are added? If the lists are empty, does it make sense that the head is none? If the list is empty, so is self a list? I'm guessing self is a list. If self if the line of self equal to 0 and return none. But then, see, that's only if the list is empty. Now, if the list isn't empty, we set the head node to none. So we do self 0 equal to none. That's the first one, and what is one piece of information the linked list should track when it's empty? I'm fucking lost. So what is one piece of information? What is one piece of info? Size? What is one piece of information? variable in a class in Python? You just fucking a variable? Oh, so I did this right before. Self that. Bro, wow. Yeah, it was just this, bro. So stupid. So this one. Close the internet. I want to trust my gut, bro. I'm thinking too hard. It should be a generator function that yields each node in length. Create a reference to the head node. Create a reference to the head node. So node equals, I guess, okay. So node equals self dot head. And then use a while loop to iterate over the linked list until node is none. Wow. Not equal. Equals none. Yield. No. Yield. Did I spell yield? What? No, see, that's supposed to be yield. No. Yield node. It said no to the next node. So next. Next. object is not an iterator. So while these walls iterate over the linked list until node is none. Now it made way more sense. Node dot next? That never did that right there. Okay. From node, import node. This one was kind of weird. Sorry I'm not talking, I'm just trying to lock in. But I guess add to tell. Time to allow our linked list to add new nodes to the end of the list. Kind of like a regular list tab, huh? So first node, the last node's fourth node. So complete the add to tail method. It adds a new node to the end of the list and returns nothing. If there isn't a head node, set the new node as the head and be done. So if there isn't a head node, set the new node as head. What? So if there isn't a head node, so I guess this is the head node, right? Or here. If there isn't a head node, set the new node as the head and be done. If there isn't a head node, set the new node as the head and be done. Otherwise, keep a reference to the last node in the list. Start with it, set to none. Start with it, set to none. Iterate one like this, we built this already. Update your last node. This is fucking frustrating, bro. I'm sorry I'm not talking today, guys. I'm just trying to lock in. I'm tired, so I'm not talking that much. If not empty, walk to the end. If actually does not equal where it is not none. itself is not none. You need to find the last node. On each step of the loop, you want to keep track of the current node. The last node is where the node on next you can run. So for so the head equals none. Damn, this visualization shit helped a lot. Now I see what the heck is happening. We add something, we add it to the tail. So say if we want to check if... I get it. Damn, bro. You know what? You know what I'm gonna do? I'm gonna just start asking for visualization, like of what the instruction is asking. Cause see, if this visualization thing was right here, bro, I don't understand what the hell is going on. I'm so confused. But now I get it. So just say let's just say the what is this called? The linked list is ABC none. So the first thing we gotta check is if the list is empty. If the list is empty, then we're just gonna set the head. If the list is empty, we're gonna set the head to none. Right. If if there isn't a head node, set the new node. Wait, what? If there isn't a head node, set the new node as a head and be done. Boom. So set the new head. So self the head to the node. Wait, if there. If self dot head is equal to none, if this is true, we're putting self dot head is equal to the node. Oh, okay, I don't mean to do that. Node. Boom. That's on a second. Otherwise, keep a reference to the last node in the list. Start with it to set to none. Start with it, set to none. So node dot tail is equal to none. Is what you want me to do? Again, it's never none. It says you ask yourself if the length is. You already checked the self dot equals none, so you know. Else list is not empty. Oh. Go over that. Else, what we're gonna do, otherwise, if and otherwise, keep a reference to the last node in the list. Instead to else, this is what I believe will happen. So now, after that, we're gonna iterate for self. We're gonna iterate, otherwise, iterate over the linked list. You built this already. Update your last node. So, okay. Whoa, I didn't mean that. So I guess we have to iterate through the linked list, but saying that we did that already. So we do this. I have to call. The thing is, this is like I'm not really good with this iter method thing. I haven't learned this like very well. Oh shit, that is right. If it's this makes it to none, right? This doesn't make sense for a few reasons. There's no node.tail. Your node class should have a .next property, not a tail. You're trying to set everything the new node. You're supposed to put in the last node of the list. Let's see the next to the point of node. Else self.next. Next is none. What do you want the loop over? You want to loop over oh yeah, so for in and self. So now we're opening this one. So once you've iterated over the entire list, your last reference should be the last node. So set the next field, the last node, to the new node. So we do node dot next is equal to the node to n. To n. I think that's gonna fuck up. If n and self. So we're getting the first one. We want to set that to this node. It won't work. This for loop doesn't make sense. For n itself, we get the first one. This for loop doesn't make sense. 100%. I'm just kind of. Oh, that should be node. So yeah, it should be node. What am I doing? You're not updating the last node next. Instead, you're saying the next on node, which means the new node points to itself, causing an infinite loop. Yeah, watch out. Also, you're doing it inside the loop, so it happens every time. But you want to update the next pointer. Oh. That makes sense. If node of n does not equal none, we're setting the n dot next equal to the node. Stop putting capitals. If n oh shit, if current if n dot next if n no, not here, no. If n dot next is equal, which is none, we could just do this. The current dot node next, the current dot next, so n dot next, if, see, this makes sense. Node, yeah, that makes sense. That makes way more sense. I should just do the same thing. I just don't know what the issue is. Once you go to the list, your last reference should be. So the last thing we need to do is just, like the visualization showed, we need to go through the n. If n to the next is none, we're gonna set the equal to the node. Equals. It's none. So iterated. The last one should be the last node, so the next, yeah, n dot next. What the fuck you wanna do? N is equal to the goddamn thing? Oh, this makes fucking sense. You said that If list is empty, set to none. Problem, you're setting node.next equal to node. I'm setting node.next. Gotta set this to none. I don't fucking get it, bro. You attach the node to the last one and those stuff. Just put a break. No, the break should be inside then. I don't fucking get it, bro. It should be easy, bro. It's not a fucking list. Like, a list is so easy. If the fucking head is none, then the self-hot head is the node. If self.head is equal to none, self.head is equal to a node. For n in self, so we're iterating through the linked list. Are you kidding me? If self.head is not self.head equals node, return last node equals node. For current node in self, the last node is equal to the current node. So last node dot set underscore next. Dude, dude, linked list is the stupidest shit in the world, bro. Just to iterate through just to append something, just to add something, bro. I gotta add to the fucking head. It should be easy though. Set the next field of the given node to the current head node. It should be easy. It has to be easy. For add a first list, we'll use to add to the front of our link list as well. So visualization would be that we get the head. We set the new node to the head. Alright? We set the new node to the head, making it adding to the head. So implement the add to head should add a new node in front of the list and return nothing. If we gotta know if there's like the test case has nothing in it, then we're just gonna do if self dot head is none. Right? If self dot head is none, then we're gonna do to the node, else the head, else the self so wait, set the next field of the given node to the current head node. Update the head reference to the given node. We set the next field. Set the next field of the given node. Set the next. I just gotta set the fucking head. So node. I don't know if this logic makes sense. define a variable called self.node in the class. Set the next field. Set the next field of the given node to the current head node. I just don't know why my brain is not fucking working, bro. Oh my god. Think, bro. Bro, like. Head node. Head node. Head node. Head node. Head fucking node. The head node needs to be shifted. We need to set the node that's given as the head. Right? So the node, no else, self dot head is equal to the node, and the self, and then so we set the head to node, and now we need to make, so node dot next is self node, is self dot head. So the self dot head equals a node. Now we need to make, so we make the head, we just made the head the node. Now we need to move that, to make the head's reference, that the previous head as the reference to the new one. Fuck, bro. So then carefully here. Changing the head before telling the new node what I should point to. So ask yourself, if I replace the self.head first, what does the self-head now point to? That, so you can't just move it to that. Makes sense. Okay, problem 2. They're calling .next as a function. So no .next is wrong. So is .next a function I should call with? Oh, fuck. I get it. So if we do self.head, we gotta set self.head to the next, and then set that to. So is it self.head next, and then we do like we gotta, okay, so I just don't know how to do it. I don't get it. I don't know how to do it in Python. It's what? It's so all I gotta do is set the fucking head to next so I can put. Make that right here. He's wrong. It's not printing all of them. It's not printing this as well. So what you want me to do? You want me to just return self. I actually don't even know. It's like bro, fuck, bro. This is like insanity. I suck so bad, bro. This guy did it. I guess I could just use set underscore next self head. Like, I didn't know about that, bro. I don't know about this shit. It doesn't fucking teach me, bro. Bro, what is this, bro? All this shit, man. Link list queue. To use our link list as fast as a queue of one pushes and pause, we need our add to tail function. Queue.
Queues are one of those data structures that you probably already understand, even if you don't know it yet. Have you ever stood in line for 2 hours just to be told that Mickey had to leave last in, first out? And queues are very similar, but they're first in, first out.
Okay, I remember. Sorry, I just had to review real quick. Dude, insane, man. Insane. To use our linked list as fast as a Q01 pushes and pops, we need a add to tail function. Function 01 currently iterates over the entire list before pending an item. So locked in queue was working just fine on a small dataset, but pending items once the list has started to take a toll on our service. Implement these changes to speed up our linked list inserts to 0 So add to head should set the tail reference to the given node if the list is empty. So add to head. Add to head should set the tail reference. So what we're doing, we're adding to tail. You wrote before you wrote add to tail. Before you wrote add to tail like this simplify for current node last node equals current node. Last under node so the last. Right, you go through everything, then you send the last one to the current node. And the last is the new node. Let's see. Yeah. So the way we do it is so make as to run all one time. This means no looping, no checking every node. Just do it instantly using a pointer to the tail. So can't I just use self.tail? The fix added dot tail pointer. Just like we already have, we put a head value of none. Now we want to add self.tail to none, right? So hold on guys, let me go use the restroom really quick. Give me like 3 minutes, please, sorry. It's 3 minutes. Alright, guys. That's it. I get it. Should be right. So add the tail should set the head. So the issue is that we're going through the for loop, so we don't want a for loop. It makes sense though. I understand why they don't want to set this to they don't want to set the, if it's empty they just want to set the tail to the node and there's nothing and we're good. Just say we're adding to tail. So okay, set the head and the tail to the given node if the list is. Self dot should be the tail equal to the node, and then after that, instead of iterating to find the last node, use the tail reference to append the new node. What? I don't get that. Instead of iterating. I see why this is here. Okay. So we're iterating through the last node. So instead of iterating to find the last node, use the tail reference to append the new node. We can append? No, we can't append. We gotta use next. So we gotta put. But instead of iterating to find the last node, use tell reference. Instead of iterating to find the last node, use the tell reference to append the new node. Instead of iterating, right? Instead of iterating, we're iterating here through each of the nodes in the self to find the last node. Use tell reference to append to new node. Oh, so we just do. No, instead of this, we just put self dot tell. We don't need none of this, right? Damn! Oh shit, we didn't do this, huh? The constructor should set self.tell to none. Fuck. So self. So self.tell. So then after this, you just do self.tell. So this just makes this equal the node. Damn. Yeah, I see why. Cause you have to make the last detail node the node. Cause if you want to update it again, it's gonna be this. If you don't, then makes sense. Okay. Okay. We're one method away from having fun. We just need to remove the first element from the linked list in constant time. When we're finished, our linked list will basically have a queue. Add to tell, constant time. Remove from head, constant. Let's rename the linked list class to LLQ. Give me 1 second. Okay, sorry, I was looking at something. So remove from head. Oh, okay, we're just doing a new thing right here. So, say we want to remove something from the head. Okay. So, if self.head wall self.head is none, return none. Step 1 is done. The head should now point to the next node in the list if there is one. Else, What? The head. So self the head. I don't know how to do that. I don't know if I'm doing this right. What is being removed? The head. The current head. So before you change anything, save a reference to it. What should self the head become? The next one. Yeah. So clue. Self dot head next is the node next. That's your new head. Oh, okay. When do you reset self dot tail equals none? After I remove the head, is the list now empty? That happens when the self dot head becomes none. If the old head dot next pointer, what happens? An old node still points to the list even though it's removed. The memory list that's a memory leak risk. Clear it by setting its dex on. Okay. So if the list is empty, return none. Boom, we did that. We should remove this tail. That should not be there. So we set the self.head dot set the underscore next node. So that's the next head is that. Then we set the tail. Save the current head. Okay. So x equals no. Let's just say the head is equals to self dot head. We saved it. Then we move the head forward. Boom. Done that. If the new head is none, also reset the tail. So if the I don't mean this. So that's a none. Wait, clear the dot next. So clear dot next on the old head. So then we do how do I do that? I have no idea how to do that. If the list is empty, just return none. Okay, we did that. The head should now point to the next node in the list, if there is one. If there isn't a head node, return none. Set a temporary reference to the current head node. Right. Update the head reference to the next node on the list. Update the head reference to the next node on the list. Okay, we can just do node dot next equals self dot head. If the new head reference is none, if self dot head, if self dot head is none, set the tail reference to equal none. Set the new node of the temp reference to none. Yeah, that should be like that. So just return none that I already did. And then there's an issue with this. But here's what's missing. You forgot to disconnect the old head. Fuck. I gotta set the old head to next to none. Yeah, it's not even defined here, so there's no way I could just do that here. Yeah. Yeah. Head is equals to none. Also set. Head is equal to self dot head. No, this doesn't work. It's the stupid next shit, bro. It's literally just that, bro. It's not none. It's the node that's just removed. It's never none in this block. It's the queue before empty. If I didn't read it, I was guessing. Let's recap a few key points about linked list queues. The problem with our array normal Python list implementation of queue, it had op and push operations. The problem with our array normal Python list implementation of queue was that op and push operations. The linked list implementation of queue is op1 push operations. Linked lists are usually worse choice than standard arrays because they use less. They are more complex for the reason they have no random. Doubly linked lists are a better choice than arrays. It's very specific. Translation on both ends. A queue made with linked lists instead of array using is faster to search through. Can have over pushes and pop. Next time, just read, bro. A queue that array doesn't have all one pushes because when elements were added. Golly, guys, I'm not gonna lie, this was rough. This was rough. I got a meeting in like 15 minutes. I'm gonna do that meeting, I'm gonna take like a 30-minute break, and then I'm gonna hop on back on this and do some leak code and try to get stronger with linked list, because God, that was rough. God. But whatever. We finished linked list. I don't know what I'm gonna do tomorrow. I gotta figure it out. But thank you if you stayed this long. I'm trash at this, so just bear with me. But yeah, see you guys later.